Exercise 9.7. Prove each of these identities. So how can we prove this one? Here, we need to know some identity formula, that is actually sin x equal to 1 by cosec x. Cosec x. Okay. Similarly, cosec x will be 1 by sin x. Then cos x will be 1 by sec x, or sec x will be 1 by cos x. Then tan x will be sin x by cos x, or cot x will be cos x divided by sin x. So from this idea, we can write another formula, that is tan x equal to 1 by cot x. Next, we know that sin² plus cos² equal to 1. Then sec² minus tan² equal to 1. And cos² minus cot² equal to 1. We need to use these identities also. Here, question number 1a. Sin x divided by tan x equal to cos x. We need to prove it. So here we know that tan x equal to sin x by cos x. So sin x divided by tan x, this is left hand side. Then we can write sin x divided by, instead of tan x, we can write sin x by cos x. Okay. Then if I do the reciprocal, because we know that if there is a division, we can convert the division into multiplication and do the reciprocal. So it will be cos x by sin x. After cancelling sin x and sin x, we will get cos x. Very simple idea. Number B. Question number B says cos x into sin x divided by tan x equal to 1 minus sin² x. So here, left hand side, it says cos x into sin x, and we know that tan x represent actually sin x by cos x. Okay. Now, this is division of a fraction. Then we can write cos x into sin x multiplied by, we need to do the reciprocal. So it can be written as cos x by sin x. After cancelling sin x and sin x, we will get cos x into cos x. That means cos² x. Cos² x can be written as 1 minus sin² x. Now, number C. Number C says 1 minus sin² x divided by cos x. We need to convert this one into cos x and we need to prove it. From the identity sin² plus cos² equal to 1, we can write cos² equal to 1 minus sin². So instead of 1 minus sin² x, we can write cos² x. So cos² x divided by cos x. After cancelling cos² x by cos x, we will get cos x. And that is actually right hand side. Now, number D. Number D, cos² x minus sin² x by cos x plus sin x. From the algebraic identity a² minus b², we can write, it can be written as a plus b into a minus b. So instead of cos² x minus sin² x, we can write cos x plus sin x into cos x minus sin x. And add denominator cos x plus sin x. Okay. Then plus sin x. If we cancel cos x plus sin x from numerator and denominator, then we have cos x minus sin x plus sin x. Then we can easily cancel sin x and sin x. Then it will be cos x at answer. Look, cos x will be the final answer of this problem. Now, number A. Number A says sin x plus cos x whole square equal to 1 plus 2 sin x cos x. So sin x plus cos x whole square. By using algebraic identity a plus b whole square, we can write a square plus 2ab plus b square. So sin square x plus cos square x plus 2 sin x into cos x. We know that sin square x plus cos square x equal to 1. So 1 plus 2 sin x into cos x. Now number f. Number f say tan square x minus sin square x equal to tan square x into sin square x. So here tan square x minus sin square x. We know that tan represent actually sin by cos. So instead of tan square x, we can write sin square x by cos square x minus sin square x. So here cos square x will be the LCM. So denominator will be cos square x and numerator will be sin square x minus sin square x into cos square x. Then from numerator we can take sin square x is a common factor. Then it will be sin square x into 1 minus cos square x divided by cos square x. Or we can write sin square x into 1 minus cos square x represent sin square x divided by cos square x. And we can say that sin square x by cos square x, that means sin x by cos x equal to 10. So tan square x into sin square x. And this is the right hand side. So in this way, we can easily prove question number F.